Welcome to the AMSE Science Report. I'm Alan Lowe, Executive Director of the American Museum of Science and Energy and the Atomic History Campus at K25, both located in Oak Ridge, Tennessee. Around 66 million years ago, an asteroid that was perhaps 9 miles wide struck the Earth, an impact that led to the extinction of the dinosaurs. What if an asteroid that large or even larger was headed toward Earth today? We've seen this scenario in books and in movies like Armageddon, but I wanted to get some expert input. So I spoke on our podcast, AMSECast, with Robin Andrews about his book, How to Kill an Asteroid, The Real Science of Planetary Defense. I first asked Robin where asteroids and comets as well originate.
Yeah, so asteroids and comets are like the leftovers from the crucible of planetary formation, billions of years ago. They're the stuff that either didn't get put into planets or got smashed out of planets later on. And asteroids are the sort of more rocky, metallic objects, and more or less they orbit the sun between Mars and Jupiter in a sort of disordered kind of highway. And comets are the sort of icy variants of those. They're often a lot bigger, and they are much further away from the sun because it's just too hot for ice to kind of build up this close to the sun. And they are kind of beyond the orbit of Neptune, mostly. But occasionally, gravitational disturbances, mainly by Jupiter, because it's just incredibly, it's absolutely massive. It sort of yanks these objects out of a calm orbit, or sometimes they smash into each other, very rarely, but that happens. And they get sent on orbits that can cross Earth, and very, very rarely these days it means that those objects hit the Earth.
Robin discussed ways we've conceived to stop an incoming asteroid, like using nuclear explosive devices or by deflecting the asteroid if it's seen soon enough by our detectors. With the latter, in 2022, there was a NASA mission called the Double Asteroid Redirection Test, or DART, that was extraordinarily successful. Here again is Robin.
No one has ever tried to deflect an asteroid before. Doing that for the first time is pretty impressive. So, to be clear, the point of the mission was there are two ways to deal with asteroids, really. At the moment, you either try and completely obliterate it, or you deflect it. And deflection is often seen as a little bit more elegant and requiring less, explosive power. So if you can do it that way, it's a good idea. NASA and Johns Hopkins University they partnered with picked an asteroid called Dimorphos, which is like a city killer sized asteroid that poses no threat to Earth, that's orbiting a bigger asteroid called Didymos, which is like the moon going around the Earth kind of thing. And they figured if they hit that small asteroid, they could measure its deflection really precisely because it's orbiting this other asteroid without launching it into space in a random direction and potentially causing problems. And they basically built the spacecraft that was it's like a ballistic missile except without the missile. It was just the targeting bit of it, this car-sized thing with an eye that could with a smart brain that could recognize where it was going, solar powered, some experimental tech. But basically they were just going to ram into this smaller asteroid, Dimorphos, and see if they could deflect it. And there was a lot of firsts in there. I mean, they could kind of pilot it, but it had to kind of do this itself. No one had tried to target such a small object before. The purpose of this spacecraft was to die. If it lived, then that was unusually for NASA, a bad thing. Yeah, it turns out they hit this asteroid dead on in the center and deflected it 25 times more effectively. They gave it 25 times more of an orbit change than their minimum threshold. So it just worked incredibly well, and it was all for the price of a luxury yacht.
After talking with Robin, I rest easier knowing that we have many eyes watching the skies for asteroids, and a number of ways to confront them should they come our way. Thanks for listening. For more information, please go to amse.org.